Pre-calculus lesson 3.2, logarithmic functions. In 3.1, we talked about exponential functions, which was just a new type of operation for us. But just like other operations, they also must have inverses. And so this is where our logarithmic functions are going to come into play. The definition of a logarithm function. So for x greater than 0 and a b greater than 0, where b is not 1, we get that y equal to log base b of x is equivalent to b to the y power equal to x. So in this case, the base b of the exponential would be the same base of the log. But notice here that our logarithm is always equal to the exponent. So a log is just going to be the same thing as saying, hey, the base to what power is x? The function f of x equal to log base b of x is the logarithmic function with base b. So let's just practice going in between the two forms of exponential to logarithmic. So in this case, what we want to make sure that we always do is we're going to ask ourselves the question, what's the base and what's the exponent? Well, if you look at the first one here, the base is 7, and the exponent here is 3. So this would be written in exponential form, 7 to the third power equals x. Similarly, on the next one, our base here is b, and since we're equal to 2, that's our exponent. So in exponential form, b squared equals 25. So remember, we're always equal to the exponent. So on the next one here, the base is 4. We're equal to y, so that's going to be our exponent. So we can think of this as 4 to the y power equals 26. Just want to be able to go between the two forms. Let's try going the other way. Let's write the exponential as a logarithm. Well, in the first one here, we have a base of 2 and an exponent of 5. So we can rewrite this as a logarithm of log base 2 of x equal to 5. Same thing on the next one. The base here is b. The exponent is 3, so we can rewrite that as log base b of 27 equal to 3. And then the last one here, we have a base of e, an exponent of y, so we can write this as log base e of 33 equal to y. But if we think back to in this case, we can think about log base e. Well, just like e was a special exponential, its inverse is also a special logarithm. This is what we call, just like e was the natural exponential, well, this is going to be the natural log, which we abbreviate as ln. And so we can rewrite this as ln of 33 equals y. These are just equivalent forms. We're going to talk about natural logs here later on. On these next couple of examples, we are actually going to evaluate these logs. So the very first step is always to rewrite it as an exponential so we can go between the forms. Go ahead and pause the video here and try rewriting these logarithms as exponentials and see if we can figure out what the exponent would be. Also note your calculator can't evaluate logs, but we need to make sure that we're able to do them by hand as well. So like on the first one here, we still are going to ask ourselves, what is the base? So this would be the same thing as saying, hey, we have a base of 10, so 10 to what power is 100? Well, if we think about 10 to what power is 100, we know that 10 squared is going to be 100. So, since a logarithm always has to be equal to the exponent, log base 10 of 100 is going to be 2. Same thing with the next one here. We have log base 5 of 1 over 125. Well, since the base here is 5, this is the same thing as 5 to what power is 1 over 125. Well, if we remember here, we need to think about that this is a fraction. So we have to think, what type of exponents give us fractions? Well, if we think back to our exponent rules, this is going to be negative exponents. Remember, negative exponents move the base to the opposite side. And so we're going from a 5 to a 1 over 125. That means it has to be negative. And so since we have a negative exponent, we know that 5 to the third power is 125. That means here that log base 5 of 1 over 125 is going to be negative 3. because we're getting that negative exponent. Let's try this one here. Notice the base here is 36. This is the same thing as saying 36 to what power equals 6? Well, notice that the base is actually larger than our value that we're trying to get to. So what type of operation makes our value smaller if we're thinking about exponents? Well, this is going to be the opposite of a power. This is actually a root, because we know that the square root of 36 is 6. But we also talked about it before when we were talking about our exponents, that we can rewrite roots as fraction exponents. So 36 to the 1/2 power is the same thing as the square root. And so, since we now have an exponent, that means we can rewrite it as a log. Remember, roots are the same thing as fraction exponents. So if we're going to write this in logarithmic form, that means here then that log base 36 of 6 is equal to the exponent of 1/2. Notice in this case, we still have a root, so that's probably going to be similar to what we used before. In this case, go ahead and notice our base here is 3. So this is 3 to what power is the 7th root of 3? Well, we talked about how before that roots are the same thing as fraction exponents. So if it's a 7th root, that would be the 1/7 power. And so this log here is going to be equal to 1/7. With logarithms, we have some properties that we need to discuss, especially those involving 1. First off, if we have log base b of b, then that's always going to be equal to 1. That's because if the base b to the first power will always just be itself. Similarly, that if we have log base b of 1, that will always be equal to 0, because it's the same thing as saying, hey, the base to what power will be 1? Well, any base to the 0 power is 1. And so, since we're always equal to the exponent, this will be 0. Let's practice these. So if we wanted to evaluate log base 9 of 9, well, notice our base here is 9. So this is the same thing as saying 9 to what power equals 9? Well, 9 to the first power. That's because it's going to be equal to itself. And so, since the base is the same as our value, it's just going to be equal to 1. On the second one here, it says log base 8 of 1. Well, this is the same thing as saying 8 to what power is 1? But as we talked about, any base to the 0 power will be 1. So it doesn't matter if it's 8, 10, -8, a million, still going to be 1. So these are using those basic properties there. As mentioned before, the logarithm is just the inverse of the exponential. So we also have these inverse properties for each other. These say that for a base greater than 0, that's not equal to 1 though, that if the base of the exponential and the base of the log are the same, then they're going to cancel each other out, leaving us with just x. So if we have a base of 2 of the exponential and log, then they're just going to cancel each other out, leaving us with the same. So let's practice using these inverse properties. For example here, it says evaluate log base 7 of 7 to the 8th power. Notice we have the exponential inside the log. But since the bases are both 7, this is the same thing as saying 7 to what power is 7 to the 8th? Well, that's just going to be 8. So those like bases are just going to cancel each other out, leaving us with that value of 8. Similarly, if we were to look at the second one, we have 3 to the log base 3 power, log base 3 of 17 power. Well, we have the logarithm inside the exponential this time. But notice they're both base 3. So using our property here, they're going to cancel each other out since they're both the same base. And so our answer is just going to be what's left over, that value of 17. Remember, the inverse of the exponential is our logarithm, so we need to make sure that we can go between those two forms. We'll explore how to graph and more properties of logs in our further lessons.